Hi friends, in this video lecture related to current electricity, first we will learn about the electric current and the cause of electric current, that is potential difference. Already we have learned in previous videos. Then we will come to the types of electric current, then sources of electric energy, that is generators and electrochemical cells, then the types of electrochemical cells, that is primary and secondary cells. Then we will come to the simplest type of primary cell, that is simple voltaic cell, and through that we will understand the mechanism in which cell provides current to external circuit, and then we will come to electromotive force of a source. After that we will obtain relationship between E.M.F, terminal potential difference, and potential drop for a cell, and using that expression we will find out the expression for total current drawn by circuit from the source, and also the expression for internal resistance of the source. So be ready with your pen and notebook to pen down the important points or to make the notes for your future revisions. So first, potential difference. In our previous videos we have learnt about the potential difference. It is the work done in taking a unit charge from one point to another within an electric field. And potential difference is the cause of electric current. It means whenever two bodies at different potentials are brought either in direct contact or connected by a conducting wire, then charge flows from a body at higher potential to the body at lower potential. It means positive charge will flow from the body at higher potential to lower potential, while negative charge flows from the body at lower potential to the body at higher potential. It means whenever bodies at different potentials are brought either in direct contact or are connected with the help of a conducting wire, charge begin to flow between them, and this rate of flow of charge is termed as electric current. So if we come to electric current, then cause of electric current is always a potential difference. It means in order to make a flow of current through a circuit, we will always be requiring a potential difference. Say if it is a conductor and I want to make the flow of current through it, then I will have to establish a potential difference across its ends, and for establishing potential difference across the ends of conductor, we will always be requiring a source of electric energy, that is either a cell or a generator. So first, electric current. Electric current is defined as the amount of charge passing through any section of conductor in 1 second. It means when charge will flow through this conductor on establishing potential difference across its ends, then how much charge is passing through any section of conductor in 1 second will give the electric current flowing through this conductor. So if charge Q flows through any section of conductor in time t, then we will say that electric current passing through the conductor will be Q upon T. If we say that there are n electrons passing through any section of conductor in time t, then one electron will have charge E, that is 1.6 into 10 to the power minus 19 coulomb. So n electrons will have charge n into E. If n electrons are passing through any section of conductor in time t, then the charge passing through any section in time t, that is Q, will be Ne. So current flowing through the conductor will be Ne by T. Electric current is fundamental physical quantity. Its SI unit is ampere, and symbol for ampere is capital A, and it can be written as 1 coulomb upon 1 second. It means 1 ampere is equal to 1 coulomb per second. And it shows that if 1 coulomb of charge passes through any section of conductor in 1 second, then electric current flowing through that conductor will be 1 ampere. It can also be represented in terms of number of electrons. And if we want to find out how many electrons will form 1 coulomb of charge, then n into 1.6 into 10 to the power minus 19 is equal to 1 coulomb, implies n is equal to 1 upon 1.6 into 10 to the power minus 19, and this will give us n is equal to 6.25 into 10 to the power. It means it will be the number of electrons that will constitute 1 coulomb of charge. So if 6.25 into 10 to the power electrons will pass through any section of metallic conductor in 1 second, then current flowing through that conductor will be 1 ampere. Now, types of electric current. Electric current is classified into two types. Actually, the type of electric current depend upon the type of potential difference applied across the ends of circuit, because the cause of electric current is potential difference only. So if the potential difference across the circuit is constant, means the magnitude as well as direction of potential difference is constant, then the current flowing through this conductor will be having same magnitude as well as same direction. And such a current that is having same magnitude as well as same direction, that is the current whose magnitude as well as direction remains the same with time, is called direct current. So the first type of current will be the direct current. Direct current is always produced by cells or batteries. Battery means the combination of two or more cells. So cells and batteries will provide direct current. Now when we come to alternating current, then alternating current will always be produced by alternating potential difference. Alternating potential difference means the potential difference whose magnitude as well as direction changes continuously with time and repeat itself in magnitude as well as in direction after a fixed interval of time. That fixed interval of time after which alternating potential difference will repeat itself in magnitude as well as in direction will be called time period of alternating potential difference. And number of times alternating potential difference will repeat itself in magnitude and direction in 1 second will give the frequency of alternating potential difference. Since electric current depends upon potential difference, so if potential difference will be changing its magnitude as well as direction with time, then current will also be changing its magnitude as well as direction with time, and such a current will be called alternating current. So alternating current is the current whose magnitude as well as direction changes with time continuously and repeats itself in magnitude and direction after a fixed interval of time. And the time interval after which the alternating current will repeat itself in magnitude as well as in direction will be called time period of alternating current. And number of times an alternating current repeats itself in magnitude as well as in direction in 1 second is called frequency of alternating current. The alternating current which is provided to our houses is having a frequency of 50 Hertz. It means alternating current provided to our houses is repeating its magnitude as well as direction 50 times in 1 second. Now, after alternating current, what is the source of alternating current? Alternating current is always produced by generators. Actually, generators in normal conditions always produce alternating current, but by suitable arrangements that alternating current can be converted into direct current, and such generators will be called direct current generators. About generators we will study afterwards in magnetism, but now we come to electrochemical cells. Electrochemical cells means the devices that are used to establish a constant potential difference across the ends of a circuit so that a constant current may flow through the circuit. That is, electrochemical cell is a device that makes a continuous flow of constant current through a circuit by establishing a constant potential difference across its ends. Electrochemical cells always convert chemical energy into electrical energy, and if we come to primary cells, then primary cells are the cells that directly convert chemical energy into electrical energy, and secondary cells are those cells in which first electrical energy is stored in the form of chemical energy, and then on demand that chemical energy is again converted into electrical energy. It means primary cells do not require any charging before their use and can be used only once, while secondary cells can be recharged again and again and hence can be used several times. The other difference between primary and secondary cells: first, the primary cell provides large internal resistance. If it provides large internal resistance, then it means it will be capable to give less current, while secondary cells provide less internal resistance. Also, the E.M.F of primary cells is comparatively less than the E.M.F of secondary cell, and later on we will discuss about what is E.M.F of source. But now we are going to learn about the working of simplest type of primary cell so that we may understand the mechanism of current flow, how a cell provides current to a external circuit. Say it is a vessel used for the making of cell. This vessel is called voltmeter. Here the simplest type of primary cell is simple voltaic cell, so I will tell you about that cell also. So voltmeter is the vessel in which cell is formed. Actually, voltmeter is the vessel in which process of electrolysis takes place. Then we will come to what is electrolysis later on, and it consists of an electrolytic solution filled in it. So here will be an electrolyte. If we come to electrolyte, electrolyte means an electrovalent compound which when dissolved in suitable solvent decomposes into its constituent ions. Say dilute H2SO4, when H2SO4 in solid state will be dissolved in suitable solvent, then it will decompose into hydrogen ions twice H plus SO4 minus minus. In the same way, if we are having NH4Cl as electrolyte, then NH4 plus Cl minus. If we are having CuSO4 as electrolyte, then Cu plus 2 SO4 minus 2. So it means the electrolyte means an electrovalent compound which when dissolved in suitable solvent decomposes into its constituent ions. Then what is electrolysis? The process of separation of ions, positive ions will move towards one side, negative ions towards another side. So process of separation of ions when electric current is passed through an electrolyte is called electrolysis. So here in cell, first thing will be voltmeter, then will be an electrolyte, and then there will be two electrodes, that is two plates dipped in electrolyte. These two plates will be made up of some suitable materials such that when dipped in electrolyte, one of them will lose electrons while the other will gain electrons. And it is the nature of these materials, and because of that nature, one of them will acquire a positive charge and hence positive potential. Say this plate has lost electrons, so it will attain positive potential and hence will be termed as anode, while the other plate, which will gain electrons, will gain in negative charge and hence negative potential and will be termed as cathode. Now it is in the nature of these materials to attain positive and negative potential, and also these materials will always have a tendency to maintain their potentials, and because of this tendency only, this arrangement can be used as a source of electrical energy, that is as a cell. If we will connect a circuit across these two terminals, that is anode and cathode, which is having a potential difference across them, then on closing the circuit, electrons will begin to move from cathode to anode, because in metallic conductors electrons are the only charge carriers. So electrons will begin to move from cathode to anode, and here if we are talking about simple voltaic cell, then this anode is made up of copper and this cathode is made up of zinc, and when dipped in electrolyte, copper can attain a positive potential of 0.46 volt, while zinc can attain a negative potential of 0.62 volt, and difference of these two potentials is electromotive force of the cell, and difference of these two potentials, E is 1.08 volt. So for simple voltaic cell, the E.M.F is 1.08 volt. The electrons supplied by cathode to the external circuit when will come to anode, and it's not like that the electrons will reach from cathode to anode. As soon as a pair of electron leaves the cathode into the external circuit, at the same moment two electrons from other end of the circuit enter into the anode. After leaving two electrons, cathode will lose its 2 units of negative charge, and hence to maintain that charge, the cathode, that is zinc plate, will lose a zinc atom into the electrolyte, and zinc atom will enter in the electrolyte in the form of zinc ion. It means zinc atom will lose 2 electrons to form zinc ion, and these 2 electrons will be retained by cathode to maintain its negative potential, while zinc atom in the form of zinc ion will enter inside the electrolyte. When these 2 electrons will reach at anode, and already I told you that as soon as 2 electrons from cathode will enter into the circuit, at the same moment 2 electrons from the circuit will enter into the anode, and as soon as they will reach the anode, they will reduce the positive potential of anode, and in order to maintain its potential, anode will attract hydrogen ions, and after giving these 2 electrons to hydrogen ions, it will form hydrogen, and this hydrogen formed at the anode will bubble out partially or completely. That will be studied later. So it means the hydrogen ions will be attracted towards the anode so that they may take electrons which are received by anode from the cathode, and in this way anode will be able to maintain its positive potential by losing those electrons which it had gained from the cathode. So in this way electrons will flow from cathode to anode, and from here also electrons will flow from, you may say, from anode to cathode, because it will attract hydrogen ions, and hydrogen ions will take electrons and will form hydrogen that will bubble out, and for those electrons which are taken by hydrogen, because of those electrons which are taken by hydrogen, the negative charge of electrolyte will increase, and to compensate this rise in negative charge, zinc atoms are entering in the form of zinc ions. These zinc ions combine with sulfate ions present in electrolyte to form ZnSO4, and during the working of cell, this ZnSO4 gets deposited at its bottom in the form of white precipitate. So it was about the working of simple voltaic cell, and when current flows through the cell, then charge not only flows in external circuit, that flows through electrodes as well as electrolyte, and since a circuit provides a position to the flow of charge, so when charge will flow, that is electric current will flow through external circuit, then current will also flow through interior of the cell, and direction of electric current means direction of flow of positive charge. In metallic conductors there is no flow of positive charge, because the only charge carriers in metallic conductors are free electrons. So free electrons are the only particles that are responsible for the flow of current. So in metallic conductors, electronic current is the real current. The flow of electrons is termed as electronic current, while we have the convention that the direction of current is the direction of motion of positive charge, and that direction is called conventional direction of current. And we must be knowing that electric current is a scalar quantity. It means it doesn't require any direction for its complete representation. Then the conventional direction only tells us about the direction in which positive charge would have moved if it were be free to move within the circuit. It means electronic current and conventional current both are directed in opposite directions, even though their magnitudes are equal. It means if the electrons are moving from negative to positive charge, we will say that positive charge is moving from positive to negative electrode. So actually conventional current will be flowing from anode to cathode, while electronic current means movement of electrons will be from cathode to anode. And since we are always concerned with conventional current, so electronic current will not be taken into account, and this conventional current will flow in external circuit from anode to cathode, and in internal circuit from cathode to anode. Whenever current will flow, that will flow through external circuit as well as through internal circuit. So the external circuit as well as internal circuit both will offer opposition to the flow of current, and this resistance or the opposition offered by external circuit to the flow of current is external resistance, and say this external resistance is R, while the opposition offered by interior of the cell means electrodes as well as electrolyte, is called internal resistance of the cell, and this internal resistance of the cell is represented by small r. And if we come to the factors on which internal resistance of cell depends, then those factors will be, first, the surface area of electrodes. Electrodes means these plates. If surface area of these plates will be more, then more ions per unit time will be able to neutralize on these electrodes. And if more ions per unit time will be able to neutralize on these electrodes, then it means this cell will be able to provide more current to the external circuit. If it will be able to provide more current, the more current means less resistance, then it means its internal resistance will be less. So first factor, this internal resistance will inversely depend upon surface area of electrodes. More surface area, less internal resistance, less surface area, more internal resistance. The second factor will be distance between the electrodes. If distance between the electrodes will be more, then current will have to travel more path through the electrolyte, and more path means more opposition. So internal resistance will be directly proportional to the distance between the electrodes. And now next is concentration and strength of electrolyte. Concentration means how much solid electrolyte is added to solvent for making the solution of electrolyte. And strength means how many positive or negative ions per unit volume are provided by our electrolyte. And for a good cell, concentration of electrolyte should neither be very large nor very small, but its strength should be large so that it may provide large number of ions per unit volume to make the conduction through the electrolyte better. Now one more factor is temperature, and if we come to temperature, then with increase in temperature, mobility of ions will increase. If ions will become more mobile, then the current flowing through electrolyte will increase. It means internal resistance will decrease. It means if temperature of electrolyte will be more, then current flowing through the electrolyte will be more. It means current supplied by the cell will be more. It means internal resistance of the cell will be less. This thing can be used to explain why vehicles are able to start quickly in summers but are not able to start as quickly in winters, because in summers, temperature being more, the internal resistance offered by the cell will be less, so it will be able to provide more current to start the vehicle. But in winters, internal resistance will be more because of less temperature, and if internal resistance will be more, then cell will be able to provide less current, and that less current will be unable to start the vehicle quickly. Now we come to electromotive force or E.M.F of a source. Electromotive force or E.M.F of a source, whether it is a cell or generator, is defined as the work done by the source in moving a unit charge throughout the circuit, including source itself. Throughout the circuit means through external circuit as well as through interior of the cell. If W is the total work done by the source in moving a charge Q0 throughout the circuit, then EMF of the source will be W by Q naught, and we know that work per unit charge is also potential or potential difference. So it means the EMF will also be having same units as potential or potential difference. So its SI unit will be volt with symbol V, and since work and charge both are scalar quantities, so EMF will also be a scalar quantity. Thus the difference between potential difference and EMF is always related to the source, while potential difference can be across any 2 points within an electric circuit or within an electric field. And electromotive force is the work done by the source in moving a unit charge throughout the circuit including source itself, while potential difference is the work done in taking a unit charge from one point to another within the circuit or within the electric field.